Good afternoon, everyone. Welcome to the discussion. My name is Simon Johnson. We're going to be talking about MQTT-SN today. I'm going to give you a bit of an overview and what it is and what aggregating gateways are, the function they perform in a typical deployment. With that, let's get started. So I get asked quite a lot what MQTT-SN is, what it stands for, and how it differs from MQTT. So this chat is going to assume that you pretty much know what MQTT is, and you're interested in knowing what MQTT-SN is and how it deviates from MQTT. So essentially, MQTT-SN is MQTT, but it's been optimized for sensor devices. That is, devices that sit at the edge of the network and are typically constrained by bandwidth, processing, and battery life. So the protocol has been optimized in terms of its packet format and life cycle to cater for these type of devices. But it's important to note that you can do pretty much everything you can do in MQTT, you can do in MQTT-SN. Both are payload agnostic, that is, you can send any kind of data you'd like from a SN sensor device in any format you would wish. And equally you can deliver any sort of payload data out to it in the same way you can with MQTT. Okay. So I've just brought up on the screen an example deployment architecture using an MQTT-SN aggregating gateway. Now the function of an aggregating gateway is to sit in between MQTT-SN clients and an MQTT broker and act as a bridge between optimized traffic on the left hand side and non-optimized traffic on the right hand side. So the gateway itself will typically be a little bit more performant than the client devices themselves, and so it will be capable of maintaining a TCP/IP connection to the broker for the lifetime of the runtime. That connection should be managed and it should be monitored. The MQTT-SN client runtime will communicate to the broker via the gateway. So the gateway will act as a conduit, and it will aggregate all the connection information required from all the different clients it has connected into a single MQTT TCP/IP connection on the broker side. So that is where n number of clients are subscribed to topic foo, a single subscription to topic foo is held by the gateway runtime to the broker, and then when a message is received from the broker to the gateway will process that down to each of the clients who care about and hold subscriptions for that message. Hopefully that's clear. So now we can get down to having a look at how a gateway runtime interacts with a client and interacts with the broker. So in front now you see I've brought up a sequence diagram that outlines the connect operation, and you can see it's quite a simple operation. This is the no-will version, which is the simple version. What we're saying is that the client is simply going to ask the gateway if it can start a new session with it, and the gateway is going to say either yes or no. And the process of making that decision is quite simple. Is the gateway awake for a start? Is it online? Has the gateway got enough capability and space to service that session? And are there ACLs present to authenticate that device to allow it onto the gateway, and in turn to allow it access to the data coming from the broker? So let's look at how that works in practice. So what I'm going to do is bring up two screens here, two CLIs. So in the blue, this represents our MQTT-SN client, and in the yellow, this represents our MQTT-SN gateway. We also have a component that I haven't got represented on the screen, which is a Mosquito broker that's running in the cloud, and that's what our MQTT-SN gateway will be talking to. So, and by the way, just so you know, all the software that I'm using today is open source software, and it's available. The client and the gateway are available from my GitHub page, and Mosquito is obviously available as an open source project as well. Right, so all of these demos you can carry out yourself in your own labs to see how it all fits together. All I've done is write wrappers, interactive wrappers around the client component and the gateway component to allow us to interact with them via the command line. Right, so first things first, we need to bring up a gateway. So we have a Mosquitto broker running in the cloud. We're going to connect our gateway to that broker. So I'm going to bring this gateway up. I've got some connection details stored in history, but essentially what the gateway needs to know is the MQTT connection details to the broker. Typically that's a client ID, host name, port, username and password. And I've got those stored for efficiency. Loading that from history. Right, so we're now running and initialized. So if I look at the status of the gateway, we can see that we've got an established MQTT broker side TCP/IP connection, and our gateway is now broadcasting its availability on the local network, and it has space for 100 connected clients, and it currently has 0 connected clients. So now let's bring up our client. I'm going to call this client Simon, so we're going to use a client ID of Simon. And we've initialized, so let's look at the status. We're not connected yet, but we've got a running runtime, queue processors running, and we can pass configuration through to it. So that being said, we're now going to run the sequence diagram that's behind these screens and get a session started. So from the client, we're going to connect. We want a clean session. We want it to be 240 seconds, keep alive. And that has gone, and it was successfully issued, and it thinks it's now connected. So if we look at this, we can see client session state is connected, time the session was started, and when the last messages were sent. And from the brokers and the gateway side, we can now look. If we run status, we can see we have 1 connected client, and if we look at the details of that session, Simon, we can see client session started. Been running 27 seconds. That's the keep alive time we passed across. Its state is currently connected. It has 0 messages in the queue and no subscriptions held at the moment. So we have now successfully issued the connect phase as per the sequence diagram and the picture behind it. So with that, let's move on. So it's a bit useless having a dormant device that's neither sending nor receiving data. So this screen highlights the subscription process, that is the client registering its interest to know about data that's sent to a given topic in the system. So if we bring our CLIs back up, from the client we can say I'd like to subscribe to topic foo, and we want it to be granted the highest quality of service. And if I look at the status now, I can see I've got a registered topic count of 1, which implies the subscription has been successfully created. And if I look at the session on the gateway for Simon, I can see 1 subscription is held at granted QoS of 2. So if we look back at the sequence diagram, we can see what's happened there. So we've issued the subscribe call from the client to the gateway. Now the gateway is decided, because it's an aggregating gateway and it's therefore only got 1 connection to the broker, it's seeing if in that 1 connection whether it's already got a subscription to topic foo. If it has already got that subscription, then it's fine. It doesn't need to create another one to its broker side. It simply needs to respond and assign that subscription to the client connection and the client session that it's being held, and ensure that the aliases are registered with that session. If it hasn't got that subscription held on the broker side, it needs to issue a subscribe to the broker, receive successful confirmation of that subscription, and then follow out the previous steps and notify back the client. So that's the subscription in place, and we now have a client that's ready to receive data on the topic foo. So if we move to the next step, and that is sending message from the device into the system to the to the broker via the gateway. So once again, if I bring the CLIs up, and I've lost my mouse, there it is. So we know we've already got a registration for topic foo. So from the device, I'm going to publish to topic foo. I'm going to publish the data hello world equals 1. Now interestingly, before I hit the carriage return here, I've already got a subscription to this topic. So what's going to happen here, in theory, is that this message is going to leave the client, it's going to go through the gateway is going to forward it on to the broker per the sequence diagram outlined here. So the publish operation comes in from the device, hits the gateway, onward delivery happens immediately before the confirmation phase to the broker, and then the gateway will respond with the requisite quality of service acknowledgement life cycle. In this case, we've used quality of service 1, so we're going to expect the gateway to send PU back to the client to notify that message has been received. But equally, that broker is going to have a registered subscription for foo to a client, to a session that the gateway is holding. So that gateway is going to receive a copy, a reflected back of that message back to itself, and because the gateway is maintaining a session for a client which also has that subscription in it for foo, that message is going to be delivered right back to the client. So this is going to be a round trip message. And there we go. So what we can see happening there, and in fact let me bring up the gateway window as well. We sent the message from the client, 11 bytes on topic foo to the remote gateway at QoS1 hello world, and moments later the message was received back reflected from the gateway or from the broker via the gateway, and we can see that the gateway was the intermediary there and was sending and receiving those messages to the client. So let's clear our history a bit, so we can clean slate. What we can see now, if we look at the status, is we have received message, sent message, count of 1, same up here, should be, receive, sent of 1, and we're all good. So moving on. And this is to receiving messages. Now we did see the client receiving a message there, and that was a very simple receipt whilst an active session was occurring, but actually the more complex life cycle and the more realistic life cycle is that a device will be out in the field and will want to sleep for long periods of time. So it will enter what's called the sleep state, and we can emulate that using our demo here. So I'm a sensor out in the field, and I've decided that I'm done for the day. I want to preserve my battery life, so I'm going to go to sleep. I'm going to sleep 240 seconds. So if I now look at my status, I can see that my client state is asleep with a keep alive 240 seconds. And if I look at my session state on the gateway, I can see that my state is asleep. So whilst I'm asleep, invariably my cellular data bearers will be powered down, my MCU will be powered down, I may well be switched off. But then when I want to wake up, I want to receive all the messages that were delivered and buffered for me whilst I was sleeping. So let's emulate that by, whilst sleeping, buffering up some messages on the gateway for that device. So I'm going to queue a message to a topic that I know that device is subscribed to, and we're going to put sleeping hello, and we'll deliver QoS1. So now if we look at his session, bearing in mind he's sleeping, we'll see that his queue size, his state is still asleep, and his queue size is 1. So that means when he decides to wake up, he has a buffered message, wake, that he receives immediately as he wakes. So he's woken up, he's received from the remote gateway, sleeping hello, and then he's immediately been sent back to sleep using the ping resp as per the sleeping life cycle. So we look at his status now. We can see that he's asleep again, and again on the client, on the gateway, we look at the status of that session. We can see that he's now asleep again. We can of course wake him back up or disconnect from here, but that outlines very simply the sleep life cycle. So there's far more to it than we've spoken about today, but that was just a bit of an overview of how an aggregating gateway works, and how it's typically used in MQTT-SN network deployment. Okay, you can get a copy of these slides if you need, just give me a ping, and with that I hope you found this interesting. Take care.